what are the shortcomings of L-diversity, okay? So we said L-diversity basically is, again, it's an improvement over k-anonymity. And because k-anonymity is susceptible to homogeneity attack, because it does not take care of, it doesn't consider the sensitive values, the sensitive attributes when doing the cut, right? So L-diversity
Yes.
is an improvement over that by enforcing or mandating that in the sensitive attribute column, there are at least L distinct or L entropy diversity, right? When you say distinct, it means that there has to be at least 3 or L distinct values in the sensitive attribute. What is the problem here is that, like if you look at the original table, right, you see
We have limitation in the sensitive attribute that will give the problem in L-diversity.
What is that? Sorry.
Limitation of.
So I'm coming into the limitation now, right? So
okay.
One of the limitations of L-diversity is that it does not consider the original distribution of sensitive values in the big table. Okay, so it only mandates that in each equivalence class you have to have L distinct values or entropy diverse values, صح? Like it does not compare it with the distribution, the original distribution of the whole table. And then we had an example. Let's say if you have a table that has, let's say, HIV patients, and one column, which is a sensitive attribute, is the test, whether they are positive or negative. And we saw that, like the distribution is very skewed toward negative. 99% are negative when 1% is positive. Now, if you wanted to create two diversity, right? Then it might be possible to have an equivalence class with 50% population, 50% negative and 50% positive, right? So we started with 1% to 99% ratio, and we ended up in an equivalence class 50% ratio. Now this is a problem, right? Why it's a problem? Because in the original table, say I identified, say, a single certain individual, then the probability that he is at HIV positive is only 1%. While in this equivalence class, if I was able to identify him in this equivalence class, then the probability is what? 50%. So that's an increase in the inference or the probability of linking him to a sensitive value, right? So so this is kind of the problem of diversity. What does T-closeness mandate or require is that the probability distribution within the equivalence class has to match the probability distribution of the whole table, right? In fact, it doesn't have to match, but it has to be within some threshold. We call it T, right? And this is the name, T-closeness. It means that the probability distribution within the equivalence class has to be close, right, to the probability distribution within some threshold T. Is that clear?
Yes.
Yeah. So this is kind of the idea of T-closeness. But again, like it's when I ask you what is the difference between T-closeness, you need to kind of step back a little bit and understand what is L-diversity, what is shortcoming, and then explain what is T-closeness. Because by itself it doesn't make any sense.
Based on my knowledge, because L-diversity is solution for the key anonymous, and T-closeness is the solution for the problem coming from L-diversity.
It's not really a solution, it's an improvement, an enhancement.
Yes, exactly. Improvement.
Right? Yeah. Right, okay, so I think we have to start the class now. So inshallah, the plan today is I will do, like for the 10 or 15 minutes, I would like to do a little bit of review, just like a couple of weeks ago. So I will randomly, or I will ask a question, and then, like I'll wait for, like I'll give you some time to think about it and raise your hand, and then I'll pick some random people. I'm not gonna pick the first guy who raised his hand. I'm just gonna randomly, and like you can share your answer whether it's right or wrong. Please, refrain from opening the slides and finding the solution or finding the answer. I would like you to think about it from your own understanding, and it's like it's You just studied that for the quiz, okay? So please don't open the slides. I trust you on this. I just want to hear your answer, and if it is wrong, if it is right, fine. You got it. If it is wrong, then we will try to reconstruct it so that you will have, you know, like the correct answer kind of printed in your brain. Okay, make sense?
Doctor, the slide about T-closeness is not in the blackboard because
please make sure that you have the latest.
Yes, I download the latest version. I couldn't find the
Yeah?
slide of T-closeness. Yes.
But it's by the way, it might have a different name. The slide is there, the same slide, but the title is different.
I think it's not available, Doctor.
It's not? طيب, I'll update that.
This slide just there.
طيب, first, if maybe it's in a different place, I will update this slide. I'm not sure because last on Tuesday on Sunday I updated the slides, also on the website, also on the Teams. So I'll double check it.
I think it's how to prevent this attack. The name of the slide.
Yeah, how to prevent that attack. Yeah, it's not T-closeness.
It is the same slide.
It is the same slide with a different title. طيب. So let's start again. I just explained it. Okay. So I will just have the roster here and just wanna anonymize it. طيب. So the first question is you know, like we talked about privacy for data publishing or data sharing, right? So the question is why do we need to share and publish data, right? So if we just concerned about that, we just, you know, like just limit sharing and publishing the data. So I'll have maybe Rada, go ahead.
For a lot of reasons, one of them is for researcher reason to make go ahead with our knowledge and make better research, and for survey reasons, like to provide a service and see what people like and what dislike, and for maybe machine learning, we cannot teach the computer without data.
Okay, very well. How about laws?
Laws?
How about laws and regulations?
Well, we need laws and regulation because we cannot.
No, what I'm saying, sometimes it's really mandated by law to share whatever data that you collected in order to be transparent, right? So that's, you know, for example, if you are, let's say, financial like a company that you have your, let's say, stocks in the market, you need to release some financial data, right? So sometimes it's mandated by law or by
yes.
Right? But absolutely, you are right. Like the other question is, what are the so you talked about, you know, like disclosures, or possible disclosure on data, and you know, like when the researcher thought about the data linkage attack and she wanted to propose a solution, she identified 3 types of disclosures. Okay. So again, I'll pick randomly. So for those who answered, give the opportunity to the other. Okay, Hussein, I cannot see for the phone. Hussein Safar, go ahead. Hussein Safar.
Yes, you can hear me.
Yeah.
We have 3 types of disclosure: membership disclosure, identification disclosure, and attribute disclosure.
Okay. So just what do you mean by, what is the difference between identification and attribute, sensitive attribute disclosure?
Identification is when to link individual to a record.
Okay.
And attribute when you get sensitive data about someone.
Very well. Thank you. طيب, if somebody can explain to me what is k-anonymity in your own word. Who is there? Abdulaziz, go ahead.
Not being be able to identify between set of people or group. Not be identifiable.
How many people? How many? What is the size of
At least 2.
At least 2?
Yeah.
Okay. That's good. So, anybody else who who would like to add? مين في أشوف شباب again I'm just choosing randomly. طيب هذا خاتم. Go ahead.
Not being able to identify a record with an equivalent class of K records.
Of K records total, right?
Yes.
Right. So Abdulaziz, when you say 2, that's very specific. K is equal to 2. But in general, right, we have K. So it has to be, each equivalence class has to be of size K or more, right? So in that case, any record will not be identified within K other records or more, of course. K or more other records. But that's usually.
But
yes.
I think he said at least 2, so I think it is valid because he said at least.
Yes, you're right, at least 2, but you are specifying, you are right. So K can take a value between 2 and n minus 1. I understand. I totally get his point. But in general, right, to be more like formal and correct, it has to be at least K values, right? Because of course, if we have K equal 100, that is also K equal 2, صح? That also T anonymity. Okay, but both are correct answers. The other question is, now we contemplated about choosing the best value of K. Can somebody give me kind of a way to choose the value of K? Not the best one, but a way to choose the value of K. By the way, and also I'm also trying to give chances to those who did not participate in the last time. طيب? So it's not only random, but also I'm trying to kind of diversify the. طيب, I'll see علي الزوري. تفضل.
Yes. We choose it depending on the records. Generally based on we choose K so that the utility and privacy are
okay,
like somewhere in the middle.
Okay, perfect. So what you're saying is choosing K is not only about privacy, but also about another factor, right? Which is the utilization. Right, exactly. So we two metrics we use to identify or and this question not to Ali, to someone else. Thank you, Ali. Two matrices we use to kind of evaluate or measure the utility. Can you give us? I don't want to give me the exact equation. I want you to give me what are the essence of these equations in your own words. أشوف عبد الله بس. Actually, go ahead, Abdullah Nasser.
Yeah, can I answer? Yeah, thank you. We have two equations to measure اللي هو error of K anonymization. We use the CDM or the general laws. For CDM, it's more focused on the quasi columns we have. So for each different quasi columns we have, it may get a different result. As for the general laws, I think it's more stable with numerical values. Yeah, okay. I think this is what you said.
So in other words, thank you, Abdullah. In other words, the discriminancy metric, just look at how big is your equivalence classes, the resulting equivalent classes, right? It doesn't care about what is the range of each quasi identifier. And the other one, the ILOS, or what is the utility, it really takes or consider the range. How big is your range? Let's say, for example, age. Is it a wider range or a smaller range? Of course, I would want my equivalence classes to have a smaller range so that I can extract more information, right? So it's two different metrics that might used for different purposes, right? So it's not it kind of complement each other. It's not like this against this, right? Sometimes I really want to use both in order to evaluate my utility. The other question is, what is L-diversity and why did we propose it, or why did researchers propose it? Let's start with what is L-diversity. I see 3 hands. خلاص, let me take الحسين إبراهيم, تفضل.
L-diversity define a number of different sensitive data in the same equivalent class. So we should have at least.
Okay.
So we should have at least L different entry for the sensitive data to gain the L diversity.
Okay, great, perfect. طب, another one. So thank you, Hussein. Why did we propose L diversity? Go ahead, Osama. The only one that has.
Sometimes for the diversity there is become a similar individual have the same sensitive data. Okay, so we need a way to make sure that there is no similar sensitive data for all of these individual and the diversity. So we make the all diversity to make them the sensitivity be different. Okay.
Okay, I see. I get your point. Thank you, Sam. That's exactly what I was looking for. Another question is, what is the difference? So Hussein and Osama mentioned about distinct diversity. There is another one which is called entropy diversity. So what is the difference between the two? What is the difference between L distinct diversity and entropy diversity? Let's choose Yemyen. Go ahead.
Sir, entropy diversity is to spread evenly the sensitive information amongst the different equivalent classes. That's what I understand.
Okay, great. طيب, okay, that's a good. But okay, so Abdullah, مين Abdullah?
Busy.
Okay, Abdullah. It might be a difficult question. What do you mean by entropy?
الانتروبي اخذناه في الفيزياء انه هو المقدار شو اسمه؟ مقدار الانتشار للشيء او
فاجأتك بالسؤال صح؟
طبعا. والله ما ادري.
I understand. طب خالد.
We mean by entropy the probability of each sensitive attribute should be equal.
Right. Okay. Yes. So it's really, like it's a little bit. أنا شفتكم الاثنين رافعين يدكم كل سؤال, so I wanted to give you a chance. You are right. It's basically what Khalid mentioned is like we want the probability of each record to be equal, or in other words, having a uniform distribution. Right. So entropy, think about it as a measure of how uniform is the distribution is. If it is a little bit skewed, the entropy is less. If it is uniform, then the entropy is high. Okay.
Sir, is it amongst equivalent classes or within one equivalent class?
Within an equivalence class, right? Because L diversity, remember, L diversity is always within an equivalence class. So is k-anonymity, so is t-closeness. Okay.
اظن اني فهمت سؤالك بشكل خاطئ. فهمت كلمه انه يشتبه معنى الانتروبي، عشان كذا توترت في الاجابه، بس الاجابه المنطقيه نفس اللي قالها خالد وهذه عارفينها يعني ما عليك.
ماشي. لا that's fine. Again, يعني whoever participated will get a point. Don't worry. طيب, we خلاص. I think I answered what is T-closeness. Abdul Karim asked me and I answered him. Now, but I think the question is, we thought, or we considered two settings for data analysis: interactive and non-interactive. If somebody can explain to me what are the differences, what are the differences between the two? Let's pick Ahmed. Ahmed Al-Maarfi.
In the interactive, the data will be anonymized. The requests will be direct from the analysis. Okay. While in the uninteractive, there will be in the middle something. The data will be anonymized in the middle before it's reach the analyst. It will be published anonymously.
Right. So in one case, the data is available. All the data is available for someone, right? For the analyst or researcher. That's the non-interactive. Okay. In the interactive, no, I'll keep it to myself as a curator, as a controller of the data, and I will only receive questions from you, and I will answer your question, right? So think about it like an Excel sheet. One way, if you want to know your grade, for example, your average, right? You just ask me, what is the average of quiz 1? And I will give you the answer. What is the average of quiz 2? And I will give you the answer, right? Or what I can do is anonymize the data, remove your IDs, and put it on my website. So everybody can get the average, standard deviation, whatever information that he wants. So that's the difference between interactive and non-interactive. But that's a good answer, I guess. We talked about another question. We talked about data reconstruction attack, right? And we saw a scenario, okay? And then we said, you know, like there are plenty of methods and controls to limit the disclosure, or kind of prevent or mitigate the data reconstruction attack. What are, you know, ways that we studied to defend from such an attack or mitigate such an attack? Let's go مجتبى.
Yes, you want me to mention one of them and talk about it?
Sure. Sure.
Okay. One of the ways is to add some noise. Like when someone asks me about like the income for someone or like that, I add extra value to it. Like if someone have 1,000 income, I will add like 200 or take 200 from the 1,000. So I don't give him the exact value. So he.
Right. That's a good answer. Okay, so thank you, Mujtaba. There is another question, related question. What is the difference between the method that Mujtaba mentioned and another method, which is adding noise to the data itself? So we said there is a data perturbation and output perturbation. What is the difference? And if you can just shed some light on why they are different, Mahmoud.
For the data perturbation, you apply the noise before you anonymize or before tabulation, whereas the output perturbation you apply after you give the you compute the answer and you give it to the analyst. Now the difference I didn't see, but it seems that when you give it to the data, so the database is responsible for that perturbation, whereas in the output perturbation, the analyst will not configure what kind of noise is applied. This is what I see from my perspective.
So again, we thank you, Mahmoud. Again, we think about it from privacy and utility. On one hand, data perturbation is more private, right? Because we're gonna inject some noise on the data itself because before we construct the statistical table. However, the problem is that we might you know, like perturb too much, so that, you know, like the data that is we want to convey to the researcher or the analyst is lost. Okay, so from privacy point of view, it's really high. From utility, it's low. On the other hand, the the output perturbation, right? We can think about it on the other spectrum. The privacy is a little bit or relatively lower, right? Because we are not adding noise to the data, but rather to the result. So to the result of the query. So it's really depending on the query that is sent by the analyst. If he is really smart and he is articulating his queries very well to achieve certain value, then no matter what noise that we are adding to the output results, he will still be able to get the information, right? From the data loss point of view, it's nothing much, right? Because let's say, for example, I give you an example. If he's asking about the average salary and we are adding only plus minus, let's say 100, 500 riyals, still within, you know, reasonable
estimation.
Estimation, yeah. Just like the estimated that we talked about.
Yeah.
Okay. Which bring me to the last question. Okay. So who's the lucky one that will answer the question? We thought the data reconstruction attack is kind of more tailored toward non-interactive settings, right? So you have a public data and then you reconstruct it. We said there are some methods to mitigate we said that output perturbation is a way, right? Output perturbation is one way. There is a method or methodology or a procedure that we talked about. What is that procedure that prevent or kind of manifest the output perturbation technique? let's say مين ما جاوب عبد الله.
I think, Doctor, it is the number of records. For example, if I have 5 records and you ask for the average, and my condition says that if the number of records is less than 5, then do not respond to this query, or give, for example, a star or something.
Okay, so that's called query set restriction, right? Yep. That's a good answer. But I was looking for another answer. Let's try Ahmed Zahran. So let me say the question again in another word. In output perturbation, you add noise to the results. Huh? We studied one method to add noise to yes or no questions. Can you explain that method? So if you're asking about a very sensitive question regarding, like an embarrassing question, what can we do in order to perturb the noise? Perturb the answer. Ahmed?
We look at the case size. We ask question if the condition here applied is less than k, we don't answer the question.
So that's almost what Abdullah answered. Actually, I was looking for another for a particular method. But anyways, thank you. Let's see another one. Ahmed Khalid Kharraz.
Yes. The method is to flip a coin. Okay. And if it's yes, we can answer the question honestly, depending on the question. And if it is no, we answer yes.
Okay. So basically, if this is called Werner's procedures, huh? Flip a coin. If you get a tail or head, depending, say yes right away. If you get the other one, head or if you get tail, you say yes. If you get head, answer honestly. Okay. So I'll stop here. Thank you, everyone. So again, we will use this method from time to time whenever we finish a particular module, just in order, for us to kind of have more interaction and kind of. I would like to hear from you. If there is this is particularly important for me because if there is something that I miss kind of explained, then it will be obvious depending on your answers. Okay. Right. Now in the second part, I would like to kind of take only one step. I promise you, toward the formal definition of differential privacy. Right. Because from last time when I explained it to the class, students had very difficult time to understand it and comprehend it really. So I said, okay, let me break it down into smaller steps, and then we're gonna have the formal, the correct definition or the complete definition of differential privacy. So maybe one step or 2 steps, okay? So depending on the time. We'll have the quiz, inshallah, for in the last 15 minutes of the class. 10 to 15 minutes. So stop me around 1:30, okay? So it'll take about 30 minutes to start this. Right.
Doctor, we will discuss the date of the exam today or next week.
Oh, right, the exam day. Well, so it's mostly likely it will be on week 8, right? During the class. But you know what? I think during the class is a little bit tight. So yeah, I totally forgot about this because we already suggested the date for the other course, and I wanted both sections to have exams around the same time, and it's easier for me. So I would suggest maybe on week 8. So now we are in week 6, 7, 8.
Week 6.
Yes. Sorry. Yeah, maybe week 8 or 9. Okay. So I would. You know what? I'll put some dates. Okay. And let's say on Doodle or whatever. And I would like to see your response, and then we'll take the majority. Of course, you will not agree on the same date. but at least we'll have, you know, like I'll see the majority. And I would say it's better to have it at evening, right? Like maybe starting from متى العشاء؟ لا بعد المغرب، يعني من الساعة 6 أو 6 ونص إلى 7 7 ونص أو حتى 8 ساعة ونص تقريبا كفاية. And then we cancel a class in that week. Is that a better option? Well, you want it during the class, but if it is during the class, we are confined to 1 hour and 15 minutes, 1 hour 20 minutes maximum.
It's a bit tight. I prefer in the evening, and if everyone
in the evening, yes.
So let's see. At least we decide in the evening. Who wants to the during the class time? Let's see the majority.
To be the same questions, يعني دكتور.
Huh? who wants the class time during the class time? So I'll give you 10 seconds exactly. So this is the okay. So during at evening time. So I'll just put the dates and maybe suggested time, and then hopefully we can have consensus on the dates. Okay.
But Doctor, we might have a problem because on Sunday and Tuesday I have classes at that time.
Yeah, Sunday and Tuesday. So خليها اثنين ربوع خميس أو يعني
ما عندي مشكلة بس يعني let's Sunday and Tuesday. It's the only
أو weekends.
لا أرجوك.
لا weekend لا دكتور.
I hate weekends.
اثنين حلو.
Anyways, and I promised you to look at the date, but I totally forgot about it. I had other things to do. Anyways,
you will send the link, then we will add the response for that.
Yes, and we'll decide next week. Okay.
Inshallah.
Actually, let's make it on week 9 because week 8 is a little bit tighter. So if we decide next week, then we'll have only 1 week to have. So let's start week 9, which is يعني week of 25 November, October, 25, 26, 27, 28, 29. طيب, week 9. I think that's good, and it will also give us time to study because differential privacy is definitely will be included. So it will give you also time to kind of comprehend it and understand it, digest it. Okay, makes sense. Right. So last time we kind of concluded our discussion about disclosure control, disclosure data control, and we ended up with this one slide, kind of with the promise of differential privacy, and we said really it's kind of an extension or an improvement of previous statistical disclosure data controls. Okay, so data privacy, just like pretty much like k-anonymity and L-diversity and T-closeness, right? One is an enhancement over the other. So think about differential privacy as an improvement over randomized response or Werner's brothers, and not really an improvement. It's also a formalization or a kind of making it more formal and proven privacy method. Okay. So I will today, inshallah, I will just start to introduce the definition of differential privacy, and then later on we will take the proof, kind of have an sense of the proof, yeah, not rigorous proof, and then some characteristic of data privacy, properties of that makes it really dominating the privacy mechanisms. Okay, so this is kind of we just talk about the definition of certain aspects, and then we'll talk about the kind of the randomized response, Werner's procedure, how we think about it as differential privacy. Okay, so we said that differential privacy give us a promise that whatever statistical model or whatever statistical data that you are providing about a database, right, should not distinguish the fact that an individual is in that database or not. Okay, so in other words, let me say it again. If you have a database that has 100 individuals and you are providing a statistical information about that database, then that response to that query should not distinguish or should not allow attackers to distinguish whether person A is really in the database or not. Okay, so you still have 100, right? But you don't want the attacker to know if person particular person, let's say A or Alice, is in that database or not. So this is the promise, and I would like to kind of give you kind of an idea how to achieve that promise or achieve that goal. And the idea is very simple. Okay, so let me give you an example. Suppose that this is the statistical data. So this is your data, right? And of course, you're not going to publish this, but you're going to publish is something called frequency histogram. You know what is a frequency histogram? Something like frequency set table that you build for k-anonymization. Basically, you take a range, each range of age, and count how many person or people are in that range. So in this case, you have, for example, so this is not a complete table. Say between 25 and 30, there is 1. Between 30 and 35, you have 2. Between 35 and 40, you have 1, and so on, right? Now, suppose that we added one more person, Alice, in this table, which age is 43. What do you think will happen to the frequency set, to the frequency histogram? Will it change? Right, it will change.
Yes.
In particular, this guy here will be added to this frequency, right? To this. Now, notice what is the diagram says. Number of HIV plus patients. See? Now, if I know that Alice is in the range of 40 and 45, and I got 2 copies of these histogram. This is the first copy, right? And then I know that Alice, which is, let's say, a neighbor of mine, who's in age of 40 and 45, got admitted where, you know, like it's responsible of releasing this data. And then later on, I queried the same, I did the same query. Give me the frequency histogram, please. Okay? And I get this answer, or this new frequency histogram. Now, immediately, I know what? I can infer that what? Alice is
she has HIV.
HIV positive, right? See the point? So, and by the way, if you want to ask me, if you are wondering, how can I create this frequency histogram? How can you create such a frequency histogram?
From the frequency set.
From what?
Frequency set.
Yeah, but how can you build a frequency set? Using interactive setting. You can ask multiple queries, صح? So in the first query, you can ask how many HIV positives in the range between 25 and 30. You will get 1. So you will build this. Then you ask the same query, right? How many HIV positive in the range between 30 and 35? You will get 2, and so on. So in fact, you're going to ask how many queries? 1, 2, 3, 4, 5, 6, 7 queries, one after the other, right? And you'll get this frequency histogram. See the point?
Yes.
Okay. Now you're gonna. Now this is, let's say in day, let's say in October. This is, you put this in October. Let's say next month in November, you did the same histogram because you are an analyst. You want to, you know, like collect data, and you got this update. Okay, this update, and you notice that there is one patient who got admitted to the hospital, or, you know, like visited the hospital last month, who contributed to kind of an increase in the frequency diagram. And by some background knowledge, you know that Alice is in that neighborhood, or who like kind of you know, like is a client to that hospital, or a patient in that hospital, who happened to have to be in 40 and 45 years old, then you definitely he is HIV positive, right? So now I would like to come back to the definition of privacy, the promise of the privacy. I said that releasing any statistical information. So we can think of frequency histogram as statistical information, right? Any statistical information should not give the adversary any information about a particular person in that database. See the point? Okay, so now because of this frequency histogram by 1, now I can know that Alice is in that table. And in fact, once I know that he is in that table, I know that, you know, like he is HIV positive. Okay, so this is kind of the promise of differential privacy.
Can you mute all, because there is a noise?
Okay, so let me mute all. Okay, is it better now?
Yes.
Right. Now, in order to have a formal definition, there are some kind of definition, some terminology definition I would like to start with, and then we will talk at the formal definition. The first thing is what is called neighboring databases. So what do we mean by neighboring databases? We have two databases, D and D prime. Okay, we said that those two databases, D and D prime, are neighbors if they differ by exactly one entry. So these, for example, this database D and this is D prime, right? They differ with only one entry. So in D, we don't have an entry for Alice, while in D prime, we have an entry for Alice. Or put it the other way around. If we remove one entry from database D prime, that will give us database D. Okay? And in fact, we are not only interested in one record, we are interested in every record. So for example, D and D bar or D prime, they are the same, right? Because they have 4 records. However, in this case, if we remove record 1, R1, now we have 2 neighboring databases, D and D prime. And how much they are differing? By 1 entry only, which is R1, right? But we can also have another set of neighboring databases by removing R2 from D prime. So now again, D and D prime are neighboring databases, which differ by R2. If we put R2 back and remove R3, still neighboring databases. If we put R3 and remove R4, still neighboring databases. So the definition of neighboring databases is that any 2 databases that differ by exactly 1 entry. See the point? And again, by entry, I mean a record. I mean a row in the table. If we remove, let's say, R1 and R2 at the same time, right? So in one database, we have R1, R2, R3, and R4. And the other database, we have only R3 and R4. That is not, or that these are not neighboring databases. So they have to differ by exactly 1 entry. So the best way to kind of think about neighboring databases is we start with the same database, a copy of each other, and then we start removing table or one record from one copy. These are neighboring databases, right? And then put it back, remove another record, and in fact, we do for all records. That will give us a set of all neighboring databases differing by 1 entry exactly. I see a question, Abdullah. Go ahead.
They have to be equal, right?
They start to have
the records.
Yeah, they have. Yeah, exactly. You have to be equal. In fact, D and D prime are exactly a copy, exactly equal in terms of records, of values, everything. They are a copy of each other, right? So D is a copy of D prime, or sorry, D prime is a copy of D, except that we just remove the information of one record. That's it. Is that clear?
Yes.
Okay. So in other words, R2 is equal, R2 in D prime is equal to R2 in D, R3 in D prime is equal to R3, and so on. Except that there is no R1. There is no record called R1 in D prime. That's it. So this is the definition of neighboring databases, and it will be clear later on when I go over the definition. Right. The second thing. The second definition that I want to explain is an idea of randomized function. I think we visited this before, but I gave you kind of an informal definition. So a randomized function or an algorithm, sometimes you call it a function or algorithm. It has some technical differences, but to us it's almost the same thing. Function is really an algorithm that uses some degree of randomness in its logic, right? So this is the definition. From now on, we will note a randomized algorithm with A, this symbol A, right? Any function, any algorithm or a function takes a domain and a range, صح? So a domain can be the databases, and the range can be any real number. Okay, so think about it like any mathematical function. It takes, let's say, so any function can take it from any value in the real number and produce another value in the range in the real number, right? But sometimes, depending on the function, you will have some limitation. For example, x can take any value, right? So let's say a function fx equal x. So basically, it's take any number in the real number and produce the same number. However, x square, right, can take any number in the real number set. And what is the range? If you have x squared, what is the range?
R.
R. So in other words, if I give it 1, if we have x squared and x equal 1, what is the output? 1, right? If it is minus 1, what is the output? What is minus 1 squared?
1.
1, right? In other words, the range of x squared is what? Positive number.
Positive.
Right? So this is the difference between domain and range. Again, this is like very simple algebra and calculus, but it's really important to understand it here, because really what x is in this randomized function is the set of the databases. Oh, sorry, yeah, the set of databases, or the set of neighboring databases that we have, D and D prime and D prime 1 and 2 and 3 and so on. So the randomized algorithm takes a database, right, and will compute some value and give us what? A result of that query. And we like to kind of formalize this output of this query as a range Y. So Y basically is the all possible outcome of that randomized algorithm. Let me give you an example. Suppose that we have this this table here, okay? Sorry. I have an example here. Suppose that I have a table here. Why it's flickering? Suppose that I have a table here, okay? I'm just, like I'm not really interested in all the columns except one column, which is a disease. Yes or no? Now, the query is, give me the number of people having this disease. Okay? So I will give it to this randomized algorithm. Okay? Of course, what is the answer of this? It's 3, sir. The randomized algorithm take this database, this column, take this attribute, compute the right value, right? And then put some noise, random noise. And suppose that the output, this algorithm, will output rather than 3, 4. So it add one more record, just to as a way of adding noise. And in fact, it can give me 5, it can give me 6, it can give me 2, it can give me 0, any value that it would like, depending on the random noise that it will add, صح? And in fact, because it's random, we like to think about it as a probabilistic function. In other words, with some probability, it will give me, the answer will be 4. With some probability, the answer will be 3. In some probability, the answer will be 2. Depends on the logic, or on the randomness, the degree of randomness this randomized algorithm is working with. So what we can do is we can think of the output of AD as a random variable. Remember, in the last time we kind of took a kind of introduction to probability, right? So I explained to you what is what random variable are, or what random variables are, right? So we said that kind of functions that take a number and relate it to what? To a probability. So let me just open that very quickly. Probability review. Okay. So basically, random variable is what? Is a function from sample space to some real number. Right? So these are the sample space. Head, give you 2, ht, th, give you 1, tt equals 0. And then for every random variable, we assign a probability. Right? Probability of x equals 0 is equal to 1 over 4. Probability of x equal 1, 1 over 2. Because we created this samples and we assigned the probability. Now, let's project it back here. Assume that AD equal 4 is a random variable. Definitely it has some probability. Or in other words, I would like to see what is the probability that this randomized algorithm will output the answer equal to 4. The answer to this question is equal to 4. What is that probability? I don't care about the value exactly, but I would just notice PR, the probability of outputting or producing 4 as a result of this function. Is that clear? Okay. So think about it as a random variable. So this probability, okay, is that's the probability of that randomized algorithm A producing 4 people as having disease, right? In other words, in another sense, or in another scenario, let's say this algorithm produces 2. What is the probability that this randomized algorithm will give 2 as a result of this question, and so on? So this is kind of a definition of the randomized algorithm and its probability. Now, the point here that I would like to make is, what happens if I remove the first record? See, so this is D and this is D prime by removing the first record. The correct answer is what? Is 2, صح? Is 2. Now, suppose that the randomized algorithm will give us 3 as a result by adding a noise of 1. What is that probability? Right? Okay. And of course, this randomized algorithm can give us 4. Can give us 4, right? Because it's randomized. So again, what is that probability? Now the idea here is if our randomized algorithm always produces 4, always give an output 4, regardless of what is the database or how many records are there in the database, right? Then we have an indistinguishability. We achieve indistinguishability, right? Because the randomized algorithm will always give us 4, regardless of that individual that is in the first record is in the database or not. Okay. Now the question is, how can we design such a randomized algorithm? So this is really the trick is how to design such a randomized algorithm, or how to kind of come up with such a randomized algorithm. Okay. So I think I'll stop here, okay, because I think this is a little bit a lot to comprehend. I would like you to, at least read the formal definition, grasp the idea of what do we mean by a randomized algorithm, what do you mean by that randomized algorithm output a certain value y from that range, y is in the range of that function, and what do you mean that what do you mean by the probability of ax is equal to y? Because again, this is really essential to understand differential privacy. And I will visit this again, inshallah, starting next class. And then we'll take the definition of the privacy. Because you see, if you did not really understand what is this quantity here, you will not understand the differential privacy. And if you don't really understand what does all neighboring data sets mean, then you will have difficulties in learning differential privacy, right? Now, one can say why we are bothering with differential privacy, since it's really difficult and it's a little bit complicated to understand, because as of now, differential privacy is dominating the privacy landscape, the privacy technology landscape. In fact, it has some practical uses, and I had some slides on where it's actually used, but I did not include it here. Now it's actually being used in a lot of in big companies, a lot of applications. I give you 2 examples. Apple, they are using differential privacy to collect the number or the usage of emojis in the iPhone keyboards, right? So, for example, they wanted to use to kind of print a frequency histogram, right? For where in the x-axis they have the emojis. Which one is used more frequently? And that is really good, because really important to kind of to enhance the user interface and user usability and so on, UI UX stuff, right? So they want to kind of put the most frequent emojis in the most used, or like in a way that is easier to use in the keyboard. So they want to design the keyboard in such a way. But again, if they collect this data, that according to GDPR and other sense, that make like a lot of privacy concerns. Suppose that someone is always using the angry face, okay, or the angry emoji, and then they always say, you know, like this guy has hard times, or you know, like some problems. So that's again that they think that this is an invasion of privacy. So Apple, they resorted to using differential privacy in order to collect or construct this histogram without, or correct this frequency histogram, right, and assuring that, right, the same results will be constructed whether you as a user of, you have an iPhone user, participated in that survey or not, or participated in that study or not. Okay, so this is one thing. The other thing is, or the other application is again, we talked about the census, data census from US, right? زي هيئة الإحصاء. They collect the survey people, and they you know, construct demographic data and so on. And they actually, you know, like found out that, you know, like it's the data that they publish is vulnerable to data reconstruction attack. So they are using differential privacy right now. And in fact, there is a website, you know, like where they collect data and actually allow users to you know, like query the data that they collected using differential privacy. Okay, so it's really, you know, like dominating the privacy technology landscape, and it's really important to understand it. It is difficult, but it's really important because, you know, like I'm sure within the 5 years or so, almost every company will, or almost every product will somehow use differential privacy as integrated solution to preserve the privacy. Okay, I think I'll stop here. So let me open the quiz. I'll time it to 15 minutes. Okay, because it's should not take that more than 15 minutes. Where is that? Okay, I think okay. So yeah, this is.
Sometimes Blackboard get hanged, and if you add 1 minute just for margin, or 30 seconds.
20 seconds.
دائما في مشاكل في البلاك يعني.
I'll give you 2 minutes. مو مشكلة. So okay, so I'll open the quiz now. Well, let's say 128, and the quiz will you know, like the quiz will disappear at 1:35. Okay, so make sure that you within the next 8 minutes or so you have you access that. Where is the timer? Set timer. Okay, so I'll put it to, let's say, 17 minutes. Okay, so it's a single attempt. So it should be opened at 1:28 exactly. So maybe at that you just refresh your website, your Blackboard page, and then you will get the now it's open now. Okay, so please make sure that you take it before 1:35, because then it will be closed. Okay, so you have 7 minutes to start the quiz, and then you have 17 minutes to finish the quiz. Yeah, good luck. I'll be here if you have any questions. Huh?